All right. Okay. Well, again, thanks for the introduction, Kathy. KTs, it's great to be with you. I know I had the opportunity to speak at the 2023 conference we had in Norfolk. That was really just a great experience, not just to be able to speak, but also to really to just meet and get to know many of you. Some of you who aren't even on the call, I haven't had a chance to meet the pleasure yet. But again, I think for my introduction, really understand my belief in kinesiotherapy, the value I think we bring. Never being in the VA setting, I can't speak to that other than my few hours of interning I did there. Certainly great work from the people I was able to engage with there. So great jobs in what we're doing there. But I think there's a real place for us outside of that setting as well. And part of that is really to understand a little about how we do those things at BioKinetics. BioKinetics is one outlet of many that I know of kinesiotherapists that are working the private practice. And today, I really like to share with you more about the technology because I feel like this could be something that really crosses over even in the VA setting. I mean, the cost of AI has come down so much as well. So I think that's a nice barrier that's been reduced in being able to allow this technology to start to inform us of our decisions, inform us even more intimately than what we can see from our naked eyes. Our trained eyes in biomechanics and anatomy and physiology, all those things we are able to understand when it comes to human movement. But certainly, AI technology is great for getting us objective data and being able to compare that data. And that's really what we'll talk about today is just a little bit of how the data works. What exactly is it? When we talk about using AI, what does that actually mean? And how do we use that to become better kinesiotherapists? And some objectives that I'd love for you to be able to glean from this session would be to understand a little about the history, especially around wearables. And then this is really today we're talking more about computer vision AI technology, so non-wearables. But even a little bit about the previous history of that, I'll speak to for a couple of minutes. And then really understanding what are the four different capabilities of using computer vision AI technology. And we'll go through each one of those and some examples of each one. And then understanding really how does that help us when we look at, again, at BioKinetics, what you'll hear a lot about is the prevention of injuries, but even in the rehabilitation of injuries, which I know many of you probably work with those types of populations who have already suffered some significant injuries or even syndromes and other illnesses that affect their movements. And what you're doing to try and help facilitate that, I think the AI technology has a place in all of our practices. And I will focus mostly on the prevention of injuries because that is our mission at BioKinetics, is to try and reduce the risk of employees getting injured in their job, therefore allowing them to have more enriching lives, not plagued by chronic pain or the conditions of injury that affect others. And then finally, just look a little bit more outside of the future. I mentioned the introduction, the speed at which the changes are happening is really exciting, but it's a little challenging because you also keep one eye focused on what's coming out of the pipe when you're hearing about new technologies, but at the same time trying to integrate what is currently today.
John, you're a little muffled.
Okay. I don't know how to troubleshoot that one necessarily. Let me try and go off camera. Let me try that. Is that any better, Kathy, to be off camera? You know, sometimes I may not.
It's still a little bit muffled.
Goodness. Okay. I can try and also join both ways. Well, I can have.
There we go. Now you're good.
Okay. Okay. If that happens again, let me know, please. Please just jump right in, interrupt me. Certainly, I don't want to be talking to myself. So thank you for that. So the last thing I was mentioning there is just learning where the technology is going. So let's jump in a little bit about the history of wearables. So in the past, we actually had markers that we would put on humans, stickers essentially that had sensors within them, and they would analyze the human movement through those markers. And as you can imagine, that's great in a lab, but very difficult in some practical settings where we all work, whether it's in the VA or it's out in the private practice. That technology was able to advance through wearable technology. So here you can see, this is about maybe 7 years old technology now, where we actually had sensors put on humans. So this little sensor on the with the clear plastic backing, which would go on someone's lapel or sorry, the back of their shirt. And then this other area here, it's an elastic band that would go around their arm. And between those two, the technology was really advanced for being able to understand the risks of injury in movements, particularly around the upper extremity and the lower extremity, the back specifically. We could actually use it on the knee as well, and that allowed us to get data around the knee in addition to the other areas. And it was great. It allowed us to, these same principles we're going to talk about right now are really the same principles you're going to hear throughout the presentation. So I want to spend some time on these because it's really the core essence of whatever the technology is. Again, mostly computer AI technology nowadays, they still use the exact same methodology. And that is to capture the risk of movement through video. And this was a big change in the journey of using wearable technology, is being able to pair it with video. Oftentimes wearable technology was used without video, and it was done throughout an entire day of someone's work. And that was fine for getting a lot of data, but it was challenging when you tried to figure out why or what movement in particular caused that risk of injury. And so being able to pair the technology with video was a big game changer back in 2017, 2018. What it allowed us to do is analyze the understanding of where the risk was. So healthcare providers could now use this objective data to understand where were the at-risk movements. Again, synchronizing that with video allowed us to be able to pinpoint the specific movements where there was a risk of injury. That then allowed us as healthcare professionals, as kinesiotherapists and others, allowed us the ability to be able to mitigate the risk of injury. So we developed something called an ABI report, which essentially used something which I spoke about in 2023, was that 3E injury prevention process. So as kinesiotherapists in the private practice setting, specifically in the occupational setting, I developed a methodology of how to think about preventing injuries. And we're going to talk about that a little bit more later, but it's important to understand the real value that we as kinesiotherapists can give to the world, whether no matter the setting, is our ability to mitigate the risk of injury, and then using the technology to, yes, analyze it and identify it, but then validate our mitigation recommendations, validate the expertise that we bring as kinesiotherapists. And the technology, it has a wonderful way of being able to do that. This is really the crux of when people say, gosh, well, Jon, how is it identifying risk? I mean, okay, so you're capturing video, great, but how is the actual risk of injury being calculated? And again, whether it's a wearable sensor or it's computer vision AI technology, this is the way in which it identifies risk. It looks at the range of movement within our joints relative to the vertical plane. And it also looks at the control of how we move our joints and access. And again, this is technology, and this is the ways in which wearable sensors capture risk. I'll look in a few minutes about how computer vision AI technology uses this, but then builds on top of it as well. You'll see the reporting later, and it's just fascinating what we're able to capture. But both the range and the control are factors of what we call load. Load is essentially the risk of injury. If you look at the report on the top right-hand part of the screen, and this was presented to the National Safety Congress in Expo back in 2019, we presented on this technology and how we used it to mitigate risk of injury. And so over in the corner, you see a 6.8. That is the overall load score or overall risk score. And within there is a tremendous amount of reporting that's capable. You can see there's video there that captures the information. If we were in a live session here, I could play that video, and at the same time as I play it, you'd see in the middle there, we have our line graphs. Those line graphs are tracking the risk of movement for the back as well as for the arm. Folks sometimes ask, Jon, why so much focus on the arm and the back? It's because shoulder and back injuries are the two most common occupational injuries. That's why we focus so much on those two particular areas of the body. Again, you could use the technology for knees and other ones. And now that we're using markerless technology with with computer vision AI, we're able to see the entire body and be able to get risk scores for each joint. So again, some of the advances you'll see in a few minutes. In the middle of this page, again, drawing your attention to the line graph, you can see there's a red line that goes across horizontally. That is the international standards for lifting and lowering. So there are standards that have been created on what risk should be within a human movement to identify if that risk could cause an injury or not. Anything above that red line is a 50% increase of a risk of injury. So we certainly want to stay below that line. And that's what this data is essentially gathering. It's gathering the risk of injury in totality for the job tasks that we observed. It's also gathering those moments when that risk was greatest. So we can look at that in two different ways. Now, I talked about the real magic of kinesiotherapists. Where can we make a difference as healthcare professionals? And this is the process I identified earlier that we created in order to bring a systematic approach to reducing the risk of injury. Again, those of you who attended the conference in 2023, you'll remember this. This was a big piece of what I spoke about. It's being able to understand how we can mitigate risk of injury as a hierarchy of controls. So a hierarchy of controls, this is a process we follow, meaning we're going to first look at ways to engineer out the risk of injury. Are there better tools? Are there better processes? Are there better materials that the employees can use to reduce the risk of an injury? It'd be the same thing as we look at our populations in the VA or elsewhere. Are there ways to be able to move around your home? Are there ways to be able to do your daily activities where you could use a tool to help reduce your risk of getting injured? Same concept that we would use in the occupational setting. Tools are great. We start with tools because oftentimes that can completely eliminate the risk of injury, if not reduce it significantly. But engineering controls are not always practical, and they can be quite expensive. And so we needed to look at what else can we do to reduce the risk of injury. Our second one is, again, within our scope of practice as kinesiotherapists. When we say ergonomics, we mean body mechanics and we mean muscle activation. Our bread and butters, our areas where as KTs, we know exactly how to make sure we position someone in a good position to be able to most efficiently complete a movement. And that's part of what we do with ergonomics. It's looking at the body mechanics of how they're actually going to move in that job position. Hey, if we can't give you a better tool to do that job, well, let's get you into a better position to do that job. And if we can't get you into a great position, we look a lot with maintenance workers, folks who actually work on the machines within factories, or even utility workers that are up working on power lines. They have to get in awkward positions oftentimes. So in those areas, we teach them about muscle activation. Again, how to engage your core muscles to take pressure off your low back, how to engage your rhomboids to reduce the stress put on your rotator cuff muscles, those small, vulnerable muscles that are that have to work sometimes overwork as stabilizers when that's not really their job. Their job is not to be a stabilizer within the shoulder joint. It's really to be a mobilizer. But when we start to use our mobilizers for stability, we increase our risk of injury. That's why we look to engage larger muscle groups that can withstand the stresses of the job and some of those extreme movements we might have to get into in order to complete the job. Now, we talked about being in awkward positions. So sometimes we can't use body mechanics as ergonomics because they have to get in awkward positions. It's in those instances where we use exercise. Again, our main modality as kinesiotherapists. We can use exercise in three ways. We can help teach those employees how to warm up their bodies to prepare themselves for physical activity. We can teach them how to reset those overused muscles. So essentially working the antagonists when the agonists are overused to complete a job task, which we see a lot in the factory setting because there's so much repetition. We want to balance or create more symmetry within the tissues. We use resetting for that. And finally, the third, strength and conditioning programs. Being able to build more resilience within the tissues that are most injured at work. And musculoskeletal injuries are significant. And that's what the technology is going to allow us to be able to start to identify. Where are those musculoskeletal risks as it comes to injuries? But I wanted to pause on this slide because the technology is very valuable. It's very helpful. But the technology just gives us data. It is using our skills as kinesiotherapists. In the occupational setting, we developed this 3E process. But in your own settings, it's using your skills as kinesiotherapists to use the technology to give a measurable result, a validated result. And you'll see that throughout the entirety as we talk about the value of the technology. So when we had those wearables on our populations, we can see here we gathered a lot of data, and we were able to start to use the 3E process to make suggestions. Here was an engineering suggestion. We said, hey, there's a tool we can, instead of you manually flipping these beams, so just to give some context here, this is a manufacturing plant where they manufacture RVs. So think about the size of an RV, a 35-foot RV, a 42-foot RV. This steel beam is actually the chassis of the RV. So with the structure, what gives it the real girth and structure and strength of the vehicle. Well, these folks were flipping these I-beams over by hand. You can see he's using his knee there for some leverage in order to be able to work different structures onto the I-beams. We said, goodness gracious, that is a injury waiting to happen to me. An arm load of 74, a back load of 58. I mean, these are some significant numbers. Again, above that red line, if you remember that. So we wanted to look at ways to reduce the risk of injury. And we looked at fabricating a tool. We worked with their maintenance department to say, hey, we want to be able to get a tool to be able to use leverage to flip that I-beam over. And so we developed that tool. And once we developed that tool, we put the sensors back on the employees, and we looked at what kind of impact did that tool make. And you can see there the data of how that change was significant. Not only did we decrease the load, so you could see the total and peak back loads were significantly reduced, over 30%. But we also actually increased the efficiency, the time it took for them to do it. So you can imagine the operators are very excited when we said, hey, not only are we going to reduce the risk of injury, but we're going to save you time of your employees to do the task. And that was, again, significant. So this is, again, putting sensors on employees. So great, good data, but as you can imagine, it presented some challenges. Number one, you had to get the sensors on people. That could be a real challenge. They might be too far away in their work settings to be able to communicate. So that was another challenge we had. So when we were able to now use computer vision AI technology, which requires no sensors at all, no markers on their body, we are simply able to use our phones or use our iPads and be able to simply video an employee working. And when we do that, we get the same exact analyzation that we had before. We're actually even going to have some added reports and added data that we weren't able to get with the markerless or the marker technology or the wearable technology. So this is markerless. That employee has nothing on them. We're simply videoing them. But again, we're going to capture, we're going to analyze, we're going to develop those mitigation techniques. Again, as experts in kinesiotherapy, what is going to be the way to reduce the risk of injury? We're going to use our 3E process at BIOKINETIX. And then we're going to remeasure as well to be able to get a validation of the risk, objective data that we can use not only in our setting where we have to convince management to spend money on things, but in any of our settings, convincing the individual themselves that, hey, by lifting your groceries in this manner, or by working around your house in this manner, this is going to reduce your risk of getting injured by X percentage. So there's application that we can have even outside of the occupational setting. And again, the entry point is much less than it used to be. So let's look at this 4 processes. So I talked about the objectives, looking at the different elements. So I want to explain how we can use this technology. It's free in this flash session. You could download an app today and be able to actually look at data. If you want to analyze the data, you want to be able to store the data, that's a subscription. There's other costs that people have for those things. But there's technology out there today where you can actually use this flash for free. Just download the app and it's able to do that. Task is being able to really start to identify. A lot of what I talked about today so far is being able to understand what the risk is. And as we gather much data, as we gather many different tasks, it starts to develop a protocol of how we can be able to start looking at injuries. Again, For those of you that might be not in the VA, but also in private practice, but maybe you're in athletic settings, you can look at certain athletes and test athlete after athlete after athlete and start to develop protocols of how to look at enhancing their performance or reducing the risk of injury. And then finally, again, like I said before, we'll talk a little bit about the future. Where is some of this predictive analysis going? Because that's pretty exciting as well. So when it comes to the Flash, I mentioned this is simply downloading an app, being able to put your camera on an individual, and you can start to identify risk of injuries. You'll see spikes, similar to how we had those orange zones and kind of red zones. We didn't have any reds at the previous slide, but you could see how those color patterns were changing. That was identifying the risk within those particular areas of the joint. So that is something where Flash allows us to do that. Task is going to require a bit more analyzation. So we're gonna dig into task now. We're gonna spend a lot of time on the task portion, because task is what's gonna give us those risks of injury, those data scores. That's gonna allow us to be able to start to use that to analyze ways in which we can reduce the risk of injury, and then being able to retest those mitigation strategies to validate their improvement. So task starts with capturing. Always going to need to capture the data. So we want to see exactly what is the injury risk there. As I said, you saw those little orange dots in his left shoulder there, his right shoulder. Those are some of the areas of risk that are being identified. And that behind the scenes, or behind the camera, so to speak, is the algorithm is analyzing those job tasks and giving us that data. The second piece is that analyzation. Right? We talked about, okay, analyzing that data. So we're capturing it. And now what are we going to do to look at analyzation? So these specific job tasks, and again, I put activity-specific mechanics there because it doesn't matter if it's a job or if it's a daily activity or it's an athletic activity for those of us that might be practicing in the athletic setting. Whatever the activity is, we want to be able to look at those mechanics and analyze the risk that those movements have for that particular activity. So those are what we're going to look at when we understand. We have the computer vision technology, but underneath the computer vision is that machine learning layer, which really is giving us the data around the risk. And then we're going to be able to capture that to create a movement library, which is going to allow us to be able to analyze similar job tasks or similar daily activities to be able to understand the risk of injury. All that's going to be able to create a custom movement analysis. So if we look in the far right there, you're going to see some advanced analytics. Now, what we're going to be looking at there is composite scoring. So really being able to understand how do movements rank within other movements. I talked about before, if we think about a good, better, and best way of doing something, we want composite scores to be able to analyze those tasks against each other, to be able to understand what is best. The risk analytics really refers to many of the risks assessments that are out there already and have been for years. The NIOSH lifting equation that was developed back in the 90s at Washington State University. REBA, being able to look at the rapid entire body assessment, or RULA, rapid upper limb assessment. These are all assessments that have been around for years that we've typically done with our eyes and maybe with goniometers and tape measures and such. And those are ways in which we're able to identify or measure risk. So those are also going to be used as part of the analysis when we look at these using computer vision technology. The joint kinematics, that's a big key part of it. The angles, the distances, velocities. I'll show you some reports on how the technology is used to be able to analyze those. The kinetics as well. So the moments and even compression forces. If we load up our weights of anything we're going to be working with, it can actually give us compression forces on our back, which is very helpful for being able to paint a more comprehensive injury risk picture, is to not only look at the kinematics, which we had with wearable technology, but now also look at the kinetics, which we now have with computer vision AI technology. The physical demands will also be part of that equation, and then the timelines. How much are we actually loading the body within these risk positions? And those are all the different components that is being analyzed through the algorithm, like through this advanced AI technology. So if we look at the reporting side of it, this is really where we start to get usable information as medical professionals, being able to understand what are the calculations and scores for the different types of areas we're looking to assess, whether that's a movement, whether it's joint movements, or its overall risk scores.
John?
Looking at,
I'm sorry, pause for a second. We're having that muffled noise. I know it will correct itself.
okay, yeah. We're testing it, so you didn't get anything.
We were doing so well.
Uh, and yet, if we need to, I think we're at, we're at the halfway point here. So I could try and get on locally through audio. It'll take a little bit of, I think, 3 or 4 minutes to do that, but it is an option in case it doesn't come through. Kathy, I'm going to try and close other applications. So hopefully I will be. I'm going to stop sharing for a second. And try and see if that might help.
While he's doing it, I just have to say this is super cool. Just to see him move the phone and to see their body parts light up, that's incredible. I mean, it absolutely transforms how we manipulate our own bodies and how we see other people manipulate their bodies. So cool.
Yeah, unfortunately, I don't have a
There we go.
ton. Yeah, okay.
You're good.
All right, let's get back to it then. I was here. Let me share my screen. And let me know if we're still sounding good.
You sound great.
All right, great. So the reporting is going to be a big part of what we're going to. We'll look at each of these reports. I didn't grab all of them, but I wanted to be able to share a few with you because I think they're really neat. And the first one is the actual overall scoring here. So I'm going to kick us back here for a second to stop. So here we look at the actual overall movement score. Just by the way, this is like being scored in school. 100% is good. So a 91 is actually a good score. Just sometimes we think, oh, 91 is really at risk. It's not. It's the other way around. But we look at those joint movements. So we talked about the shoulder moments, the low back moments, as well as the low back compression. All that's being analyzed when we look at the risk of joints. The reach envelope, you'll see this later on when we talk about how do we use our expertise as kinesiotherapists to be able to reduce the risk of injury. The reach envelope is really important. The REBA scores I mentioned before, again, a rapid entire body assessment score. So those are great ways for us to be able to quickly identify risk of injury for the entire body. And then if we look at some of the other ones that are out there, these are some of the NIOSH lifting equation. I talked about that. So again, created by the University or Washington State University back in the 90s. For those of you who aren't familiar with it, those factors on the bottom is really what is being objected. Again, this is something you can do without the technology as well. We used to use this equation all the time in 2005, 2010. Before we had even marker technology, we were using the NIOSH lifting equation. So looking at the horizontal location of whatever you're lifting, lowering, pushing, or pulling, the vertical location, the distance of which one has to travel when they picked up. Again, it's a lifting equation, so we're lifting up the materials. The asymmetrical angles that represents when we go through the lift, the frequency of which we're able to do that, and is there coupling. So here in this particular example, this is actually a pretty good score. It's less than an hour. Lifting index is 0.6. That's not so bad. The REBA, so again, the rapid entire body assessment. So you can see a little bit of what that's looking at. All this, again, used to be done by hand. We used to have to, write in these measurements for ourselves. And then eventually on the bottom right, you see their overall score. That score is a factor of all these different scores that we would have to give of each one of those movements. Look at the neck, the trunk, the legs, the upper arm, the lower arm, the wrist. All those are being calculated for us now. So you can imagine the efficiency side of this is incredible. It's just how quickly we're able to assess them. Again, we're just popping our phones on and being able to analyze these folks as they're working. We're not asking them to stop their work. We're just simply recording them as they work. So it's a tremendous amount of data. Some more data that we're looking at as well as we talked about the kinetics. So the movement or the moments that we have with the Newton meters that we're seeing there, the left side shoulder in that particular task was a little more rigorous in its use than the right-hand side was. The low back moment as well, you can see that's pretty low compared to what we had on the shoulder. I mentioned compression. So compression, this chart here on the bottom left is going to introduce those first two standardized lines for the computer vision AI technology. So we had this back in the wearable technology where I had that red line going across. I told you it was an increase of 50% increased risk of injury. These are a little different in the standpoint that there's two. The yellow one represents anything above 3,400 newtons. According to NIOSH, that is the back compression action limit. So anything above that yellow line increased the risk of low back for some workers, depending on their conditions, whereas the red line at 6,400 newtons increases the risk of a low back injury for really most workers. And so those are areas we want to stay lower than when possible. So we look at that spike there, and what we would do if we were analyzing this on our dashboard, we would time that spike up with the video and see, oh, that's what they were doing. They got that really big spike in their low back compression when they twisted instead of pivoting their feet. We'll see that quite a bit. So an employee might be doing a repetitive task. You'll see in a few minutes looking at employee tasks who are in warehouses. And a lot of repetition, you can imagine, in a warehouse. Constantly material handling, lifting, lowering, pushing, pulling. And when we see them doing that, we always talk about, hey, pivot, don't twist. Meaning move your feet when you're going to lift something and move it from point A to point B. Don't twist by keeping your feet stationary, and now that compression force goes onto your back instead of being no compression force because you're actually moving your feet. So those are some examples of how we want to reduce the risk of injury and look at those moments and say, hey, let's pair up the video with the spike in risk, and we can start to mitigate those injuries, again, in the occupational setting using the 3E mitigation process. Finally, look at the kinematics before we move on to the next reports. The kinematics overview here. So we're looking at angles of all the different areas of the joints. You could see in those line or bar graphs, below those line graphs, it's going to tell us just how long we stayed in different positions. Look at the low back there. Moderate flexion, so 20 degrees to 60 degrees. We spent a lot of time in that area. So that's why we got a bit of a back score that we want to make sure we reduce. Again, not significant and incredibly dangerous, but something where we can see above that red line there on the top with the flexion, we want to make sure that we're looking to reduce that. And even some of the other areas there, you can see they didn't quite cross the red line, but they're over the yellow line quite a bit. So again, that would be an area we want to look to reduce the risk of. How can we eliminate this flexion? Can we eliminate it altogether? Can we bring it up into the mild flexion area? What can we do to look to mitigate that risk of injury? So the last two reports we want to look, or sorry, last report we want to look at, these two different section here would be the task score. So this is the actual algorithm of the company who actually creates this technology, this 3Motion AI. They have a task score. So again, it's inverted. You can see the higher we or closer we are to 100, the better off we are. But we can see in some of those moments, we drop below those thresholds. And again, we want to pair up the video with those particular areas to see, hey, what were we doing during those times to be able to see that. And it's paired up for us. We don't have to do that ourselves. The software allows us to be able to pair that up when we're on our dashboard. And then finally, the risk in REBA, again, anything above that red line, we want to make sure we kind of look to reduce the risk of injury. We can see it in the green lines there for the legs and trunk. Our overall score pierced that moment as well. So provides us the data to start to say, okay, what can we do now to reduce the risk of injury? So when we talk about these types of ways to reduce the risk, we want to look at as much data as we can. There's probably some of you on the line right now thinking like, gosh, is this going to vary quite a bit, John? If you have a 5'3" employee doing a particular job task and a 6'3" employee doing the same job task, aren't they going to get different scores? And absolutely, they're going to get different scores. And so that's why I want to look at these job tasks in aggregate or in totality. So lots of different employees, we want to be able to gather that information for to really get an overall score of that risk. I'll talk in a couple slides about why we want to look at individual employees as well. But when we look at being able to mitigate an entire job task, in this case, you can see they're all material handling. They're all doing warehouse type work. When we want to look to mitigate that, we want a lot of data. We want rich data. We want data that's going to be able to give us an accurate picture of what exactly is the problem. So then when we look to mitigate something, again, using a tool or using different techniques, we can see, are those widespread impacts, or are those impacts only for certain populations? So here we look at our overall movement scores, an 82. Again, not bad, but we can start to see we're getting down towards that yellow. So we want to look at where would that risk be. Now, this reach envelope here, we see there's 75% of the time they're over shoulder height. You know, obviously, as kinesiotherapists, experts in biomechanics and anatomy, we know, hey, if we could be in the power zone between our shoulder height and our mid-thigh height, that's a good place to be. That's where we want to really focus, because our joints aren't in as excessive range of motion as they would be above our shoulder, especially for some of our populations who are older. They might have impingement syndromes or other ways that could even exacerbate the risk of injury by working above their shoulder, or even, again, moving, getting cans of soup out of their top shelves. We want to make sure we look at our geriatric populations, and what can we do to keep things in that shoulder to knuckle area where we only had 24% of the movements there, whereas 75% of the movements were above that area. So that is an area we want to look at. How can we reduce this risk of injury? Again, not a great risk, but if it's performed all day, you can see our recommendations to reduce risk of injury. We want to look at how to be able to reduce that risk. And so it's important, again, to look at things in aggregate. Now, there are times we want to look at individual analysis. Again, you know, obviously my background or my population is workers, but if you had athletes, even if you had veterans coming into the clinic, looking at those individuals analysis is a great way to be able to understand that. And we've had these out there in other ways. You know, we probably have heard of FMS, functional movement screens, or SFMA, which we have on the screen here. Again, it's a screen that's been done since late 90s, developed by physical therapists. Those SFMAs have been used for athletes. They've been used for non-athletes. We used them for many years by actually eyeballing the employees moving and giving them scores. This is the same scoring system. It's just now we're using technology to be able to identify where that risk is. So these are risks of injuries doing, you can see several movements on the left there where employees are being identified for different movement positions. And how well do they move? How functional are they in that movement? If you could see, if they reported pain, we had an X there. But if they could be able to do it, but they weren't able to do it all that well, we can see we ranked these movements of which ones they did well and which ones they didn't do as well. And so we saw the squat and touch, the cervical extension, the upper extremity extension. These are areas where we want to look at being able to enhance their functionality. In the occupational setting, we may do that through exercise, both at work and at home. And I would imagine the same thing for many of our populations on the phone. We want to be able to start to create exercises that we can use to mitigate those risks of injuries and enhance the overall functionality of that employee or that individual. And being able to rescore, using the technology to rescore the SFMA movements. So when it comes to job tasks, again, this can be expanded beyond just job tasks into any population that you may work with. I want to really practically apply this technology right now. So we kind of talked about how it works in theory, how it works with its reporting, its analytics, but now I want to really showcase an example of how can this be practically used, how we use it today in the occupational setting. So first, we're going to start with capturing. Talked about this already many times. So just being able to get data into the system to be able to have it be analyzed. Then that analyzation is going to be done in those manners we talked about. So the 2D computer tracking, as well as the 3D machine learning, being able to look at all those different risk factors for understanding where is that risk of injury. We talked about the composite scoring, the analytics, all those different types of the NIOSH, the RULA, the REBA, those risk analytics, the joints, looking at the kinematics as well as the kinetics. And then finally, looking at what are the actual demands, the heights, the durations, the frequencies, and the time of which someone's going to be able to perform this job task. All that's being done to analyze the risk of injury. And then this is what it would provide for us. It would provide what is the actual score that an employee would have for this particular job task. So here we're looking at someone in a factory, and they're actually getting materials from the bottom shelf. So you can see, I mean, obviously, many of us on the right now and looking at the screen are probably jumping out of our seats, seeing that person, with the way they're bending down to get those materials. Unfortunately, this happens all too often. That's our job as medical professionals, is to educate these folks on how to do that better. So we looked at, okay, that when they have to get down to the bottom shelf and be able to pull those items for the assembly line, that is an increased risk of injury. We had an overall risk here of an 80. That was significant risk of injury in the upper body as well as the lower body. So those risks are identified there. And now we want to look at, okay, what can we do to then mitigate that risk? So what are we going to use? We're going to use that 3E injury prevention process. So what can we do first to look at engineering out the risk? It's our number one go-to. It's the way we want to be able to reduce the risk of injury. If we can't use a tool or a different process or a different setup, yes, we would look to ergonomics. How can we move our body better to reduce the risk of injury, or how can we use muscles to reduce our risk of injury to more vulnerable structures? Or even exercise, how can we build more resilience within the tissues to reduce the risk of exercise, or how can we risk of injury, or how can we warm up beforehand or reset? But fortunately, in this case, we had an engineering solution. And the engineering solution here, stuck on the screen here. Let's see if we can. Kathy, help me out here. Can you see the screen?
I can see the screen.
Okay. All right. I had a little bit of a jump there. Okay, so here is what we did, is we used that 3 injury process. In this case, you can look at the description of changes here on the left. We actually removed that entire lower shelf. We didn't even give them the option to use that anymore. We actually took the materials that were on the lowest shelf, and we had some room on the upper shelf and the middle shelf to be able to actually change where they were going to be accessing these. And you can see a dramatic reduction in the risk of injury. So we had a 74% risk of injury overall. We had a 100% risk of injury reduction in the legs. So that was an incredibly good piece of what we do. Now, as healthcare professionals, we want to look at, where did that change come from? And so we can look at here, before the change, we had a 75% of the time was shoulder to knuckle. Not bad, but we had 20% of the time knuckle to floor. And that was really where we saw that spike, that blue line go through the red line up on pierce the increased risk of injury. So we want to look at, and you can see on the low back angles, we have a lot of risk there as well. But if we remove that bottom shelf, we can completely eliminate the risk of knuckle to floor. That knuckle to floor after shelf height change, if you look at the reach envelope, 0% knuckle to floor. Significant reduction in the injury. And as well as the reach envelope as well for the forward reach. We have 100% of the time they're working within the power zone, something closer to them, versus working overhead at 26%. So now the real piece comes as the second piece of kinesiotherapy, right? We talk about using exercise as our modality, but our second modality is education. And what we developed at BIOKINETIX was incorporating that second piece of our kinesiotherapy background, education, into something called walk off with one education. So here is really where we just say, this is what we're going to deliver to the employees. And this is what you could deliver to your athletes or to your veterans. It's kind of like the boiled down education. Hey, this is what I want you to be able to do. In this case, we're working in a factory. This person's worked there for many, many years. Has gotten materials from that bottom shelf for over 10 years. And now all of a sudden that bottom shelf isn't there. That can be a significant change to someone's life. It doesn't seem like a big deal to us, but just imagine doing the same job for 10 years and someone comes in and says, oh, we're going to do it this way instead. You can't just make that change without pairing it with some education about why that change is good for them. And so this walk off with education, which is 2 to 3 minutes in length. These are short topics really focused on just exactly what they need to do differently, or in this case, why they need to do that differently. And we share the data with those employees as well. I would encourage you to share the data with your populations as well. Oftentimes we used to think, we made the mistake of saying, well, let's not get into the numbers with the employees or the data. They don't care about that. They just tell them what to do. Like we just need to tell them what to do. And that was a really big mistake. Couldn't have been any wrong or more wrong about that, because they in fact appreciate the data. The data starts to build more resonancy with why they would actually make this change, or why that change was made for them in this case. And so sharing the data with your populations would be something I would heavily encourage, because it gives them the why behind the change that's being made. Or if you're looking at changing their mechanics or their structure, this is why they would want to go make that change. The last piece I wanted to discuss here was the prediction. So where are we going in the future? What's happening? And a lot of it starts to come with the use of big data. We hear that term quite a bit. Well, every day, we, as many other providers of injury prevention techniques in our little field of occupational injury prevention, in addition to all the people using this technology in sports and all the people using technology in other areas, all that data is being amassed, and it's starting to create historical trends and give us really insight into population norms. This is going to go far beyond the data that we're just gathering, the groups that we're affecting with our data. It's going to be able to start to identify where opportunities are at a population level. We look at probabilities of injuries, and this is very, very important for the insurance industry. The insurance industry, as they underwrite these policies for workers' compensation, the more they can have an understanding about what the risk of injury is, the more precise they can underwrite those policies. And you can imagine a significant cost reduction could be gained if they understood where to reduce those risks and what the proper way to write those insurance policies are. So predicting claim duration, estimating the claim cost, those are all the areas where this technology is going. It's really going, again, this is my little world of occupational injury reduction, but it's really going to drive big data metrics in being able to reduce the overall cost associated with this. Now, to some degree, that'll trickle down to all of us in some value, but it can certainly be used within your populations to identify historical trends and population norms as well, as more and more data is being gathered. So hopefully by now you understand a little about the history of the wearable technology and how that compares to the computer vision AI technology within injury prevention, the 4 different capabilities of computer vision AI technology, being able to understand just how we can use this to validate what we've done for so many years. As kinesiotherapists, we've been able to look at risk, whether it's in movements or it's risk of an injury, and being able to make recommendations. But now we have a data to pair with us, and understanding where that data is going to go in the future, and how it's going to be looked at in more of big macro developments when it comes to using the data and understand what the impacts can be for whatever population that we might be serving. So Kathy, if there's questions, I'd be happy to take some. I can jump in the chat myself if you'd like.
We do. Do you have the ability to analyze someone's gait and posture with this technology?
Oh, yes. Yep. It's exactly a big part of what it's doing. Yeah. Gait is, it follows the human, like it's just, again, simply follow it with your iPad or your iPhone. But absolutely, you can look at those. Anything else?
Another question, if I can paraphrase it right, is, so do the employees come to you and say, I have this repeat injury, can you come take a look at it? Or is it the company that says, take a look at all my employees and tell me what's going on?
Oh man, great question. Great question. Okay, so here's the journey that typically happens within a setting. So just to give you a little perspective, we'll hire medical professionals and they're W-2 employees of ours, and we embed them into those facilities or into that region. If it's like a utility, they cover certain regions because they'll go out with the employees to different, people's homes or businesses, and they'll do analyzations out in the field. But we are there every day. So in the beginning, when they don't know us and they don't really, it might be new oftentimes. We have many clients that have never done this before. And so during that initial month to 2 or even 3 months, the company really guides us on, hey, we looked at our loss runs or we looked at our injury reports, and these 4 job tasks or these 8 job tasks are really where we had most of our injuries. Let's go analyze these. And that gets us started. But as we start to develop relationships, because again, we're leading warm-up programs, we're helping people one-on-one with issues that I have a sore shoulder for the last 10 years. What can I do for it? Okay, we're going to use some kinesiotherapy techniques or maybe some hands-on techniques as well to help mitigate that. As those folks start to understand who we are and trust us and develop that rapport, it is absolutely the employees that then start to talk to us, like, hey, can you come look at my job task too? Because I've been doing this job for a while, and it always bothers me when I do this, and I just felt like there must be a better way. Or oftentimes employees have actually identified what is a better way, but the company might not be listening to them. And so they want us to come over there and use objective data to make the case for them to the decision makers at the company of saying, hey, this is the reduction in risk you can have by doing it the way this employee has been asking for several years. And that's the helpful way of being able to convince the employer to spend the money or to make that change. So it comes both ways. It comes both ways.
Next question is, do you think it could get to a point where it can generate an exercise plan for them to assist with injury prevention?
Oh, it absolutely does. Yes, it does. So it does that already. Yep, I didn't even get into that. I mean, an hour is a little hard time to talk about this technology, so I didn't quite jump into that. But yes, it absolutely has what they call corrective exercises that are recommended based on the scores that they have.
Do you fear that with all this AI, we will lose the human touch?
So what I've seen for us, it's really been an enhancement. I mean, here at least I can speak mostly in my own little world here of workers of injuries. Companies, they have this data, like they'll oftentimes just get this technology and start either they don't use it, so they need someone to actually go out and do the analyzations, the capturing as I talked about, or B, they capture. No one's analyzing it because they just get so much data that they don't know what to do with it. So as medical professionals, no, I don't. I mean, someday maybe it is not the immediate future. The immediate future is there is going to be an influx of need of medical professionals to enact solutions, to solution development, like that 3E process. We are brought in from Zurich, from Gallagher Bassett. I mean, just all these insurance companies come seek us because companies don't have the solutions because they're either operators or they're safety professionals. They're not medical professionals. They don't understand how to reduce risk within the body. And so the opposite is really we're seeing as true is where we're being tapped more and more to be able to come in as subject matter experts to develop solutions to reduce the risk of injury.
Does the video need to be taken live, or can a video get uploaded for assessment?
Wow, great question. Great question. It can be both. Yeah, that just came out maybe like a year ago. That changed where we used to have to capture it live, but now no, we have again safety professionals because sometimes we're in like a plant that might be 1,000 people, but there's a same company has a plant where there's 100 people, and so we're not going to go visit a plant with only 100 people. So those employees, those workers, or even the safety professionals or safety team members, they'll actually just take videos on their iPhones and they'll send it to us, and we can scrub it, analyze it through the algorithm, and it gives us the same data as it would as if we were doing it live.
It's incredible. Could this serve as an avenue to have workplaces give time for employees to exercise for injury prevention?
It absolutely does. I mean, so right now at some of our clients, we have them warm up for either 3, 5, or 10 minutes before their job tasks, before their job starts. And we do it, kind of have fun with it. We have one of the employees lead. Even on construction sites, we have it being done to music. Sometimes we'll just use dynamic movements with no resistance. Sometimes we'll use TheraBand, or we have some proprietary tools we use for resistance. So they're doing that as a warm up. But then in certain other companies will have it where they do the warm up, but then they go do those individual corrective exercises I talked about a couple minutes ago, where those are individualized based on their scores that they had during their SFMA. And they'll actually the company gives them 10 extra minutes to do their exercises. So it happens. It's not, that second part isn't widespread. Warm-up programs are very common now. So they are giving time for that, but the specific ones, it happens. It's not widespread, but it is getting more prevalent, especially in areas like utilities where they have a lot more time.
Have you looked into expanding your tech outside of occupational realm into nursing homes and or home health agencies to use this tech with patients?
Gosh, I haven't, but if someone on the call is willing to do that, that'd be wonderful. The technology is free, or is able to use by anybody. So that would certainly be a good application of it. But we have more work than we have people for in the occupational setting.
Hey, what a great thing for KT to do as part of the profession. It would be certainly a wonderful way to move us into the next decade for sure.
I mean, again, Kathy, I've talked about it many times here with you and probably to some on the phone. Just my kinesiotherapy background has been a huge ace in the hole for me as I gone out and be able to, I did the work for many years myself, analyzing. It's doing what we were trained to do. It's body mechanics, analyzation, it's developing solutions, both individually for, individual employees, but also macro solutions on changing the work to be able to reduce injuries based on body mechanics. It's all within our realm. It's all within our expertise.
So cool. Amazing. Anyone else have any other questions? You certainly can unmute yourself and ask, or put it in the chat and I'll ask for you. This is amazing, and I'm going to have this up on the website by the end of the day. I'm going to rewatch it. It's overwhelming. It's so much information, and it's just so cool, the things that you were able to do. And I can absolutely see how this can be applicable for everybody going forward. And I'm just so grateful for you and your expertise and your time that you continually give to us. It's amazing. I'm really, really, really grateful for that.
You bet.
Thank you.
Looking forward to the next time to see everyone.
Also, for those that had like a phone as their identity, we're gonna need more information if you want a certificate. So,
Okay, what information do you need?
your name.
Oh, my name is up there. I'm putting it in now. Thank
Okay.
you.
Thank you.
Okay. Thank you.
301 too, pretty good. We made it.
Fantastic.
Yeah, great participation. Thank you.
Thank you.
Kathy, this is Mark Frazier. My wife's computer is the only one that I have available to me, and so
I got that, Mark.
yeah, all right. I figured it out.
Some of you I recognize. Thanks.
Yeah, thanks.
And Kelly, just to give a selfish plug, always looking for kinesiologists to serve our team. Like I said before, I think we have one or two that made it just last week. So, like I said, we have more work than we do with people. So, go on LinkedIn and apply.
It's warbly again.
Yeah, you're broken up a little bit, but he's got more work than he can handle, and he hires KTs, which we are thrilled about. It's amazing, and there's definitely a way forward in private practice, and you've shown us that, and that's the future for KTs outside the VA. So we will keep connected and keep you connected to our students, and as things mature, we'll keep sending you the best of the best, and just so grateful for that opportunity as well. And thankful that everyone was able to show up at this time, and glad that it worked out. We had a great turnout, and we'll be here again next Wednesday at 3 p.m. Eastern, noon Pacific, and all the times in between. You can figure that out for yourselves. And just love seeing your faces and your names pop up and having this opportunity to be with you. It's fantastic. So thank you all very, very much, and we'll see you next week.
All right. Thanks again. Take care, everyone.
All right. Bye-bye. Are we leaving?